It's interesting. Ohayou gozaimasu. So remember this 2 weeks we had the theme for Japan. Okay, so we'll come up with let's come up with some background in Japan. Oh, it's very good. You take action so quickly. So 3.2, we're going to talk about the product and quotient rules. In 3.1, we have the sum and difference rule, right? So we said the derivative of the sum is the sum of the derivative, and the derivative of the difference is the difference of the derivative, right? Those are the sum and difference rules, okay? Now in 3.2, we have the product rule. So if you take the derivative of the product, okay, now intuitively you might think it's f prime times g prime, right? However, it turned out to be a little bit different. It is the derivative of the first function f times the second function g, okay, and then adding the first function f times the derivative of the second function. So the proof of this is on page 184. Okay, so this is the product rule. Okay, so I'm not going to prove it. Okay, it's going to take a little bit longer to do it. So you will read the book and read the proof. Okay, so and if you're interested in that, and I can go over that with you individually. Okay, now let's use this product rule to find derivative. We start with this simple function, x squared times x to the third power. We know that if we simplify this function, we get x to the fifth power. And now we can use the power rule to differentiate that. Okay, can someone tell me what's the derivative of x to the fifth power?
Is it 5 times x to the 4?
Yes, you got it. 5 times x to the 4 power.
Yeah.
So our answer should be 5 times x to the 4 power. Now let's use the product rule on this and see if we come up with the same answer over here. Okay. So according to the product rule, we're going to differentiate the first function, which is this one. And then we times the second function. And adding, now the first function, you just copy, and then times the derivative for the second function. So it's like they take turn to differentiate. Okay. So I like to keep it this way. I differentiate the first function here times the second. The first function times the derivative of the second function. Okay. Now the derivative of x squared, it is, you guys can speak up if you guys know the answer. Okay. So that is 2x. Now times this x cubed. And I'm adding x to the second power times, what's the derivative of x to the third power?
3x squared.
3x squared, right? Okay, you got it. So this will be 2x to the 4 power, adding 3x to the 4 power, which is 5x to the 4 power. And that agree with this result. Oh, it's good, right? Okay.
Yes.
Right. So now you got this. Okay. So we got the same result, 5x to the 4 power. Okay. Which is the same result when you simplify the function and differentiate using the power rule. Now, be very careful. The derivative x squared times x cubed is not the derivative of x squared times the derivative of x cubed. Okay, they are not equal. Okay? These two are not equal. This side over here, we got 5x to the 4 power. We just discover that the derivative of this is 5x to the 4 power. Now, if we differentiate x squared, we got 2x. If we differentiate x cubed, we got 3x squared. And multiply this, we got 6x to the third power, which is not the same as this. So this is not equal to this, okay? So the product rule, remember. Okay, now look at this example 2. To differentiate this function, notice that this is a product. It's this function times this function, okay? So we'll use the product rule. So the product rule says that we'll differentiate the first function. So differentiate the first function times the second function over here, adding the first function times the derivative of the second function. That's the product rule. So they take turn to differentiate. Differentiate x, what do you get? Anyone?
1.
1? Yes, 1. Now times this second function e to the x, adding this first function x times the derivative of this second function e to the x. What's the derivative of e to the x? E to the x itself. You got it. Okay. Now we can take out this common factor, e to the x. So over here in the parentheses, we'll put 1 plus x. This is the first derivative of this function. Okay. Now I take out this common factor and write this result in this product form. I want to discover a pattern for the end derivative of this function. Okay. Now I will continue to differentiate this. So I will get to the second derivative. So because this is a product, we're going to use the product rule. So we're going to differentiate the first function and then times the second function, adding the first function times the derivative of the second function. Right here. Okay. So what's the derivative of this? The derivative of 1 is, what's the derivative of constant? It is 0, right? And then the derivative of x here, it is what? 1, okay? And then times e to the x over here, adding. Now this first function you just copy, so you have 1 plus x. Now times the derivative of e to the x here, that will be e to the x. Now again, these two have the common factor, e to the x. We can take out this common factor, e to the x. So take out this e to the x. Now we combine this 1 plus 1 plus x. 1 plus 1 plus x is 2 plus x. So we put 2 plus x over here. Okay, so that's the second derivative. Now, I don't know if you, can you guys find a pattern? What do you think about the third derivative? Do you see a pattern? What will be the third derivative of that function?
Is it going to be 3 plus x times e to the x?
You got it, okay? So 3 plus x times e to the x. You see, the reason for that is because, you see, whenever you differentiate this, right? And then you have one extra e to the x over here in front, okay? So that's why here is going, this number is going to increase by 1. So now increase to 3, okay? Okay, now the end derivative of the function. So according to pattern, so this will be what, everyone?
N plus x.
N plus x times e to the x, right? Okay, good. This is the end derivative of this function, x times e to the x. Isn't that interesting? Now you can surprise your friend. I know the 100 derivative of this. What's the 100 derivative of this function? 100 plus x times e to the x, right?
Yeah.
Now you can impress your friends. Okay. Any question? Okay, the third example over here. Okay. So f of t is equal to the square root of t times parenthesis a plus b t. Okay. Now I will first rewrite this in this power form. Instead of square root of t, I write it as t to the 1/2 power. Because we know how to differentiate using the power rule, so it's better to rewrite this, use the power, okay? Now notice that a and b over here, they represent constants. In our book and other textbook, we usually use a and b to represent constants, okay? Now let's do it 2 different ways, okay? The first solution, the way that we do over here, we're going to use the product rule. So we're going to use a product rule because this is a product. So it's this times this. It's a product of this function with this function. So use the product rule, we're going to differentiate the first function. It will be t to the 1/2 power. Okay, so differentiate that. So differentiate this function times the second function. Adding the first function over here times the duality of the second function. Okay, that's the product rule. Okay, what's the duality of t to the 1/2 power? Let's find out. Okay, t to the 1/2 power. Okay, we can use a power rule to differentiate this, right? According to the power rule, what do we get here?
Is it half t?
Yeah, it is 1/2.
To the power of negative 1/2?
Yes, t to the
Negative 1/2?
negative 1/2 power. You got it. Okay. So you bring this exponent in front and decrease this exponent here by 1. So you get negative 1/2 here. Now let's rewrite this using the radical form. Okay. So that will be 1 over 2 square root of t. We encounter this very often. Okay. So we have done it over here using the power rule. How about we just remember this as a formula now? So we don't have to do this over and over again. So I would suggest that you remember the duality of square root of t as 1 over 2 square root of t. Okay, so go back over here. So the duality of t to the 1/2 power here will be 1 over 2 square root of t. Okay. Now times this second function here plus t to the 1/2 power times the duality of this second function. Okay, now remember a and b are constant. So the duality of a will be 0 because the duality of constant will be 0. What's the duality of bt? Think about what's the duality of phi t with respect to t. So duality of phi t over here, it is phi. So the duality of bt here will be b. Okay, just like that. So that will be b over here. Okay. Now we want to combine these two. Okay. Now t to the 1/2 power is square root of t. Okay. So if I want to combine these two terms, I would like to have the least common denominator. So that will be 2 times square root of t. So I put down 2 times square root of t here as the least common denominator. And up here, I will have this a plus bt. And then adding. Now this one here, b times square root of t. B times square root of t. If I change the denominator here as 2 square root of t, I will multiply up and down here by 2 square root of t. Multiply the numerator denominator here by 2 square root of t. I'll have 2 square root of t here in the denominator. Now notice that square root of t times square root of t here, it is t. So you get 2b times t over here. So over here, we'll put down 2b t. Okay. Now you combine like term over here, you get a plus 3bt over 2 square root of t. Okay. Any question? Okay. Now let's do it a different way. Okay. So I'm going to do it a different way, the second solution. we'll first simplify the function first before we differentiate. So we will distribute this square root of t inside this parenthesis over this addition. So over here we got a times square root of t, and then here will be b times t times square root of t. All right, now let's rewrite this, use the power form because we had to use the power rule to differentiate. So we go ahead and rewrite them using the power form. So this will be a times t to the what power? 1/2. Yes. And then b times t to the what power?
3/2.
3/2. Yes, you got it. Okay. So t times square root of t, that is t to the first power times t to the 1/2 power. So when you combine the exponent, you get this 3/2 power over here. Okay. Now after I rewrite them using the power form, okay, I'm going to differentiate. Now I don't use the product rule because this is a sum. So I just use the sum rule over here. So I'm going to differentiate this and then adding the duality of this. Okay. Now differentiate this. Let's see what we get. The duality. So you see over here, this a here is a constant multiple. So we bring it in front. So we have a times. Okay. Now I see if you guys remember, what's the duality of t to the 1/2 power? We just did it up above. You got it. Okay. It is 1/2 square root of t. I said that we will remember that as a formula now. We have done that using the power rule. So the duality of square root of t, or t to the 1/2 power, is 1/2 square root of t by the power rule. Okay, now over here, this b is a constant multiple, so we bring it in front of this. So we have this b times the duality of this. The duality of this will use the power rule. So we get 3/2 power, okay, times t to the what power?
1/2.
1/2.
1/2.
Yes, you got it. Okay, 1/2 power. So the exponent here decreased by 1, right? Now let's rewrite this. Use this common denominator. So we have 2 square root of t here, and then here we'll have this a plus this one here. If I have this, using this common denominator, so that will be 3bt here. Okay. Now, do you guys, okay, so some of you might wonder, how did you get this? So this part over here it is. So this is 3b t to the 1/2 power over 2. Now, if we want the denominator to have 2 square root of t, so over here, if you multiply square root of t up and down, so you have 2 square root of t in the denominator, 3b, t to the 1/2 power times t to the 1/2 power, so you have a t here. So you have 3bt up here. So that's how you got this. Okay. Okay, now you see the result here is the same as the one that we got by the first. You look at this answer over here. It's the same result we got by using first method, right? Using the product rule. Okay. However, which one is a little bit simpler to you? Which one you think is simpler? Looks like the second way is simpler, right? It's a little bit simpler. Because the sum rule is simpler than the product rule. So when you do homework, whenever possible, you will first simplify the function first. See if you can simplify it. Simplify that first and then differentiate. Okay. Now, number 4. This one over here, giving you this function, which is the product of this one and this one, where we get, we also know the duality of the function g at 4 is equal to 3, and g of 4 is equal to 2. We try to find the duality of this function f when x equal to 4. So first, if I try to find this, I will need to find the duality of this function first. So I'm going to differentiate this function. Because this is in the form of a product, so we're going to use the product rule. So we're going to differentiate the first function, and then we times the second function, adding the first function times the duality of the second function, right? Okay. Now we already remember this duality of square root of x is what? Anyone? 1 over 2 square root of x, right? Okay. Remember, we said we try to remember as a formula, okay? Now times g of x, adding square root of x here times the duality of g. All right. So now we can substitute. We're trying to find f prime of 4. So we're going to substitute 4 into x. Okay. So we substitute 4 into x to find f prime of 4. So simplify here, we got 1, 4. And g of 4, what is g of 4? It is 2, right? It was given. Now adding over here will be 2, right? And g prime of 4 was given to be what?
3.
3. So do the calculation. So 6.5. So, however, in website, just want to give you a heads up. In website, they don't like mixed number. They want the answer here in improper fraction. They think that this one here is kind of confused with 6 times 1/2. So they prefer you to leave answer here in improper fraction. So 13 over 2. So this is what website want. Okay. All right. So the next rule that I want to go over will be the quotient rule. The quotient rule says that if you differentiate a quotient of two functions, okay, providing that this function down here is not equal to 0, that's equal to this quotient here. Denominator will be the square of this g, and then up here will be the duality of f times this g here. And now here is subtracting. Subtracting this function on top, which is f, times the duality of this function down here. So I put it in this way so you can relate this with the product rule. The product rule here will be adding, right? But then the quotient rule here is subtracting, okay? So f prime g subtracting f g prime, and then all of this over g squared, okay? I'm not going to prove it today, and the proof of this is on page 187, okay? Okay, now let's use this quotient rule to differentiate this quotient, okay? Now let's first simplify this. Simplify this, we got x cubed. The duality of x cubed is 3x squared. Now let's use the quotient rule, see if we come up with the same answer here. So according to the quotient rule, so what do we get here? So what's in the denominator? It's the square of the denominator, right? So square of x squared. Now up here, what should I put? The duality of x to the 5th power. The duality of this function up here times this function down here, x squared. And in between, it is subtraction. And then now, x to the 5th is just copy times the duality of the function in the denominator. Okay. Now this is x to the 4 power in the denominator. The derivative of x to the 5th power is 5x to the 4. Now times x squared. This is x to the 5th times what? Now you guys can answer along the way if you feel comfortable. Times the derivative of x squared, it is 2x. So this is x to the 4 power. This is 5x to the 6th power, subtracting 2 times x to the 6th power. So which is going to be 3x to the 6th power over x to the 4 power. So simplify this, we got 3x squared, which is the same result over here, right? Okay. Now, example 2. We're given this function. We try to find the tangent of this function at this point. So you'll see this in your homework, okay? So to do that, I would like to ask you to do this, okay? You first check if this point is on the curve. If this point is not on the curve, then you cannot do it, okay? So I'm going to check if this point is on this curve by substituting x to be 1, y to be e over 2. So I substitute y to be e over 2, x to be 1. Now this side is e over 2, this side is also e over 2, so it check. So yes. So this point is indeed on the curve. Now the second step here, so we try to find the equation of the tangent at this point on the curve, right? So to write the equation of a straight line, we need one point, okay, and we also need the slope. So we already got one point, we just need the slope. The slope of the curve corresponds to the first derivative of the function. So we're going to differentiate this function, okay? Now what kind of rule do I need to use to differentiate this?
Quotient?
Quotient rule? Yeah. So we use the quotient rule. Okay. So according to the quotient rule, we'll square the denominator. Okay. And then we differentiate the numerator on top times this function in the denominator, subtracting. Now this function in the numerator, just copy, times the derivative of this function in the denominator. Okay. So that's equal to, simplify, 1 plus x squared and then square. Okay. Derivative of e to the x is e to the x, and then times this. Now, notice that this step over here you can skip in the future. You can go straight to this step here, okay? But because this is in the beginning, so I write down every step, okay? So this is e to the x times, what's the derivative of this? Derivative of 1 is 0. Derivative of x squared, it is
2x.
2x, right? Okay. All right, so now we simplify this. We can take out this common factor e to the x, okay? So we have e to the x times 1. Now remember, this one over here, it is minus 2x, right? You see this minus 2x over here? Minus 2x, I put it here. And then adding x squared. So I put it this way, 1 here, minus 2x over here, adding x squared over here, okay? Now, do you guys recognize this inside the parenthesis? What is this? This is a perfect square, right? What perfect square is that? Perfect square of
X
what?
minus 1?
X minus 1, yes, you got it, okay? So you can leave it this way, or you can rewrite this as x minus 1 perfect square. Okay, now this is the derivative of the function. Now we can find the slope of the tangent at this point. by plugging in x equal to 1. So x coordinate is equal to 1, and this point is on the curve. So we plug x equal to 1 into the duality here to find the slope of the tangent. So substitute 1 into x over here, you get e to the first power, and now you have this 1 minus 1 square, and down here you have 1 plus 1, and then here square, right? 1 minus 1, here it is going to be 0. So this part here is 0. So we get 0. 0 divided by a non-zero quantity is 0. Okay? So we got 0. Now, when the slope of the tangent is equal to 0, that means we have a horizontal tangent. Okay. Now, that tangent line passing this point right here. Okay. So passing this point with the slope equal to 0. So we will horizontal line. The equation for this horizontal line here will be y equal to the y coordinate of this point over here. Okay. So y equal to e over 2 is the equation for this horizontal tangent. Now, if some of you don't recognize this, you can use the point slope form to write this equation of this tangent. So y minus y1 equal to the slope times parenthesis x minus x1. You also get the same result. Y equal to e over 2 is the equation of the tangent over here. Okay, right? Any question? Okay, now let's summarize what we have done today. Actually, summarize the 3.1 and 3.2, the formula that we have discovered so far. Okay, so duality of a constant with respect to x. What's the duality of a constant? Anyone?
0.
Yeah, that's equal to 0. Okay, so duality x to the n.
nx to the n minus 1.
You got it. N times x to the n minus 1. Okay, e to the x.
E to the x.
You got it. E to the x. Okay, now this is a constant multiple rule. Okay, you have a constant times this function. Then this constant you can bring in front of this duality. So you have this constant times the duality of this function f. And this is the sum and difference rule. So duality of the sum is the sum of the duality. Duality of the difference is the difference of the duality. Okay. Now the product rule. Okay. Now without looking at your note. Okay. Can you guys tell me what's the product rule? What's the duality of f times g? Will be f what? Duality of f times what?
G.
G. Okay. Yeah. And adding
F
f
times the
times
derivative of g.
duality of g. You got it. Okay. Okay. Now the quotient rule. Okay. So the duality of f over g here. The denominator here will be g squared, right? What's in the numerator? F prime times g, and then
Minus f.
minus
Yeah.
f
F times the g prime.
g prime. Yes, you got it. Okay. All right. Now I put it in this order. Now you can see that it kind of relates to the product rule, right? So kind of similar, except this is the sum, this is the difference, right? Okay. Now I offer you one homework help over here. Now in your homework, you have this function. They ask you to differentiate this. So looking at this, it looks like you have to use the quotient rule because it's a quotient, right? However, we can actually simplify it first. We can simplify this by taking every term up here, divide by this common denominator. So you have this divided by x plus this one divided by x. And then you simplify it, right? Okay, simplify and put it in power form. So what do we get? So this is 3x plus 2 times x to the what power? Negative 1/2 power. Okay, over here, square root of x over x, that is x to the 1/2 power over x to the first power, right? So you got x to the negative 1/2 power. You subtract the exponent. 1/2 subtract 1 is negative 1/2. Okay. Okay. Now you simplify it and then write that in a power form. Now you can differentiate. Now you don't need to use the quotient rule. Okay. So differentiate this. Okay. What's the derivative of this? 3. Right. Derivative of that is 3. And then the derivative of this here will be what? 2 times. What's the derivative x to the negative 1/2 power? Use the power rule. What do you get?
So negative 1/2 x to the power of negative 3/2.
Yes. So negative 1/2 will drop to the front here. Okay. And then times x to the negative
3/2.
3/2 power. You got it. Okay. So this exponent over here is going to decrease by 1. So it's negative 3/2. Now you can just simplify this. So you get 3 and then minus 1 over x to the 3/2 power. And that's the answer over here. Okay, so you don't have to use the quotient rule. So when possible, simplify the function first. Okay, you can divide by this common denominator and express them turn by turn and then differentiate that. Okay, all right, we're done with 3.2. Okay, so today we went over the product rule and quotient rule. Okay, and they are very important. So practice on them. Practice make perfect. Okay, I'm gonna stop share. Okay. Okay, any question? No question. So you guys have fun. I'll let you guys know how it goes.